In a revelation that could fundamentally reshape humanity's understanding of its place in the cosmos, scientists announced the detection of an unusual and highly structured signal originating from the direction of Proxima B, the closest known potentially habitable exoplanet to Earth. Located just over 4 light-years away, practically a neighbor in cosmic terms, it sits within the Alpha Centauri system, the nearest stellar system beyond our own Sun. The signal, faint yet unmistakably organized, immediately triggered a wave of excitement, caution, and unease across the global scientific community. It was not random noise. It had form. It had structure. And most importantly, it had persistence. For the first time in human history, the ancient question, "Are we alone?" stopped feeling philosophical and began to feel observational. Proxima B orbits Proxima Centauri, a small red dwarf star far dimmer and cooler than the Sun. Despite its size, it anchors one of the most intriguing planetary systems ever discovered. Since its discovery, Proxima B has been considered one of the strongest candidates for habitability beyond Earth. Not because it is Earth-like in comfort, but because it exists in the narrow region where liquid water could, under the right conditions, survive. The planet is rocky, slightly larger than Earth, and close enough that modern astronomy can study it indirectly through advanced spectroscopy and long-range radio observation. But this signal changed everything. It did not resemble any known natural astrophysical emission. Pulsars, stellar flares, magnetospheric bursts, and background plasma noise were all quickly ruled out. It also did not resemble typical human-made interference. Satellites, Earth-based transmitters, and orbital reflections were eliminated after cross-verification across multiple observatories. What remained was something far more difficult to explain. A narrowband radio emission, locked into a tight frequency range, showing a subtle drift pattern over time. That drift mattered. It suggested motion consistent with a rotating planetary source, something tied to a world rather than floating randomly in space. In earlier analyses, this anomaly was catalogued under a temporary designation used for unexplained candidates in radio astronomy surveys. But its behavior set it apart. It appeared only when telescopes were precisely aligned with Proxima Centauri, and vanished when the observational angle shifted even slightly. This positional dependency made random interference extremely unlikely. The signal persisted intermittently for nearly 30 hours before fading completely into silence. And then it left behind something even more unsettling, no explanation that fully satisfied all constraints. To understand the significance of this detection, one must understand the environment in which it originated. The Alpha Centauri system is not a simple star arrangement. It is a gravitationally bound trio, Alpha Centauri A, Alpha Centauri B, and the distant red dwarf Proxima Centauri. Among them, Proxima is the smallest, faintest, and most unstable, but it hosts the most intriguing world. Proxima B orbits extremely close to its star, far closer than Mercury orbits the Sun. At first glance, such proximity suggests a scorched, lifeless surface. But Proxima Centauri's low luminosity changes the equation entirely. The planet receives enough energy to potentially sustain liquid water, placing it in a narrow and delicate habitable zone. Its estimated mass and radius suggest a rocky composition similar to Earth, raising the possibility of a solid surface, atmosphere, and long-term chemical stability. In theory, conditions could allow oceans to exist. And where oceans exist, chemistry becomes unpredictable. And where chemistry becomes unpredictable, life becomes a statistical possibility. That is what made the signal so significant. It did not merely suggest a phenomenon, it suggested context. A world capable of supporting complexity. And perhaps something more. The scientific response was immediate and disciplined. Extraordinary claims require extraordinary evidence, and every possible natural explanation was re-examined. Research teams searched for hidden interference sources, instrument errors, atmospheric distortions, and rare plasma effects that could mimic structured radio patterns. Most candidate signals fail at this stage. They collapse under scrutiny into familiar categories of noise. This one did not. Its narrow spectral signature remained stable under repeated analysis. It was not chaotic like stellar emissions. It was not broadband like natural cosmic background radiation. It resembled something constrained, deliberate, filtered. And that interpretation, even if cautious, changed everything. Speculation emerged across scientific circles. Could this be a leakage from an advanced communication system? A natural phenomenon not yet understood? Or a rare alignment of astrophysical processes that imitates intelligence? Each possibility carried profound implications. If natural, it would reveal new physics. If artificial, it would redefine humanity's place in the universe. Beyond science, the discovery triggered philosophical and ethical debate. If another intelligence exists so close in cosmic terms, should humanity attempt a response? Who would speak for Earth? And what message could possibly be appropriate for a first contact scenario we barely understand? Meanwhile, modern observational technology became central to the investigation. Instruments capable of analyzing exoplanet atmospheres were reoriented toward Proxima B. Advanced infrared observatories began searching for chemical signatures, oxygen, methane, carbon dioxide, and other potential biosignatures in the planet's thin atmospheric envelope. Even slight anomalies in atmospheric composition could support or weaken the case for biological activity. At the same time, radio telescopes around the world coordinated long-term monitoring campaigns, scanning for repetition, modulation, or recurrence of the signal. The key question remained unanswered. Was this a one-time event, or part of a repeating pattern? If repetition were found, the implications would escalate dramatically. Because repetition implies structure. And structure often implies origin. Proxima B now stands at the center of one of the most compelling scientific questions of the modern era. Do nearby worlds remain silent because they are empty? Or because we have simply not been listening correctly? Across the galaxy, thousands of exoplanets have been catalogued. Some are gas giants larger than Jupiter. Others are rocky worlds with inhabitable zones, potentially similar to Earth. Among them, Proxima B is unique not because it is the best candidate for life, but because it is the closest. If intelligence exists elsewhere in the galaxy, distance is usually the barrier. Here, distance is almost negligible on a cosmic scale. That proximity transforms probability into urgency. Even a faint signal becomes significant when it comes from the nearest stellar neighbor. As analysis continues, caution remains essential. Many extraordinary signals in astronomy eventually resolve into natural explanations. Yet the possibility cannot be dismissed that humanity has, for the first time, detected something not produced by nature alone. Something structured. Something intentional. Something that may not be human. Regardless of its origin, the signal has already changed science. It has forced instruments to become more precise, models to become more flexible, and scientists to become more patient. It has also changed perception. The universe no longer feels silent in the same way it once did. It feels monitored, measured, perhaps even shared. And as telescopes continue to watch Proxima B, one question remains suspended across the scientific world. If this was a message, even a fragment of one, the most important question is not what it says. It is whether we are truly ready to understand it.